So now we're ready to discuss one of the most important concepts in algebra that's then carried forward into calculus, and that's the difference quotient. So the difference quotient, bottom line, is considered to be an average rate of change. So to draw you a picture of what it is we're actually studying here, we're going to start with the first quadrant in the XY plane. Just keep things very, very general and basic. I'll go ahead now and sketch in a curve, our function y equals f of x, and then put in there a secant line. Now, a secant line is a line that intersects the curve in at least two spots. So our points of intersection would be there and there. Now, you can see our line, our secant line, is doing approximately what our function is. Now, it's not exact, but in the case of how we're studying this, we would view this as an average rate of change over the interval. Now, the interval that we're talking about would be this interval right here, where if I came straight down from that point, I would have an x value. The horizontal distance between the 2 points we would call h, and then the remaining x value would consequentially be x plus h. So over the interval x to x plus h, our secant line is doing approximately what our actual function is, and so that's what's going to give us the average rate of change on that interval. Now, the y coordinates, specifically right here, this would be f of x, and then similarly, this would be f of x plus h. So if we're meant to study approximately what the curve is doing, and by convenience, we're studying what the line is doing, really what we're going to be focusing in on is the slope. And we know the slope is the change of y over the change of x. So for us, the slope of the secant line specifically would be the change of y values divided by the change of x values. Now, in the denominator, you can certainly write your x plus h minus your x for this guy and minus this guy, which obviously would also simplify too, but should be noted that of course your change of x is going to be the h coordinate. So this right here, the slope of the secant line, f of x plus h minus f of x all over h, this is what's called the difference quotient. Okay, so let's go ahead and take a look at the next example. In example 7, we're given a function, and we're told to find the difference quotient and simplify. So let's just remind ourselves how function notation works, and if we go nice and slow through this, the setup shouldn't be too bad. So looking here at the difference quotient, the first part that I would do is I would go to function f, and every place I see an x, I'm going to put an x. So that's going to give us a 3 plus 2 times x plus h minus x plus h quantity squared. Now, continuing down with the difference quotient, we have our minus, so I'll put a minus there, followed by the actual function itself. So be a little careful here. It'll always be subtracting the entire original function, so we'll need to put those parentheses around there and make sure we distribute the negative. And then finally, all of that is over h. So I'll put an h on the bottom there. Now, our goal in this whole process is to clearly clean it up and draw some conclusions, but short term, we want to get rid of this h. That h has got to go. So pretty conveniently, if we clean up the numerator, it should take care of itself. So let's see, if I distribute the 2, whoops, there's an x plus 2h, and then we'll expand that out, x squared plus 2xh plus h squared. Distribute the negative, all over h. And then one more step of distributing that negative. We'd have a minus x squared minus 2xh minus h squared. And that whole thing is over h. Now, as I mentioned before, pretty conveniently, this thing takes care of itself. And so notice, if you did this correctly, everything in the numerator without an h should go away. So, for example, the negative x squared and the positive x squared, 0 out. The 3 and the negative 3, the 2x and the negative 2x, leaving us with just these three terms, all of which have an h in common. Since all of them have an h in common, we can factor it out, leaving us with a 2 minus 2x minus h. And that h in the denominator that we wanted to get rid of from the start now divides off, leaving us with a final answer of 2 minus 2x minus h.